Yeah, so let me first start by giving you an overview of the first half of the course. So we divided it up into three modules. So in the first module, we talked about data, how you sort of understand the properties and quality of the data, how you might visualize. So you do that usually by statistical analysis. We also talked about, real world data often not being clean, and how do you figure out, how much noise there is in your data. So we talked about those issues by looking at statistical methods. But another way to understand the data is by visualization. So we talked about some standard visualization methods that they could use to understand data. So that was the first part, or the first module of the course. And in the other two modules, we covered machine learning techniques, the basic machine learning techniques. So the second one was on supervised learning, like regression methods and classification algorithms. And the third part of the course was on unsupervised learning, which are clustering algorithms. So we went through a number of clustering algorithms. So the way we delivered this course was we covered the basic material in lecture format using slides, and students had access to all of them. We gave them reading material, but then we tried to keep it hands-on. So associated with every lecture, at the end of the lecture, the TA came on and used Google Colab, and I'll tell you a little more about it soon, as well as example data sets to illustrate the concepts that had been covered in the class before. This had not only the advantage of connecting what students had learned conceptually to how they applied it to data, but they also learned about a couple of important tools that we use a lot in computer science. One of them is Google Colab, and it's a tool that you can, instead of having to write programs from scratch, which of course computer science and engineering students are quite familiar with, but others may not be, it allows you to create scripts. So for example, if you were to do a program to process some data set, you could provide a lot of the initialization routines, a lot of the structure of what they would have to fill in, and let students just fill in specific details. So this is called a scripting language. So this enabled students who did not have a very strong background in programming to still run pretty sophisticated analysis routines. So we use Google Colab. Along with that, we use GitHub, which is a repository. The advantage of GitHub, or the way we used it for this particular course, was we were able to store a lot of the data in GitHub repositories. Students worked. They had accounts, GitHub accounts, so they used that to create their own programs, run them, generate results, and save it back in the GitHub repository. That's why when when they had questions, they could either email or contact the TA and the teaching assistant, and they would look at their work, and he could give them specific feedback. So that was the advantage of the structure that we set up. So I already mentioned about these in-class demos to provide learning support, and then students worked on assignments as homework, just to make sure that they felt confident that they understood the use of the algorithm. But when they needed to, they could interact with the TA and get help in finishing up these assignments.